Hello, good day, and welcome back to the BK Consult. Making proper reference to our previous videos, we've been able to practicalize how we can turn a simple architectural drawing into a simple structural frame, and these frames are known as our general arrangement or simply the GA. So if you want to know how we got to this point, I will leave a link in the description and also a link to this architectural plan, so you can as well go ahead and create this very simple structural frame or general arrangement. And remember, I said after this stage we will be moving to the modeling, which we'll be using Prota-Structure version 2018. We'll be moving on to the modeling stage, and after the modeling stage we'll look at the pre-analysis analysis of the structure, the design of the structures to get the suitable members, and also the detailing of the members that we've gotten at the design stage. With that being said, let's begin what we've scheduled for this other lecture. Let me show you what we aim to model. So one thing that is very important to know in software is that it makes a lot of things easier for you, but in the process of making this complex calculations and the rest easy for you, it also works with the concept of garbage in and garbage out. Whatever you give to the software, it's what is going to give to you. Modeling of this structure has to do a lot with your own concepts and your clear understanding of how you intend on connecting all these members together in order to have a very stable structure. This is a finished 3D of that very model, and it is being displayed on Revit. So when you finish the design and we'll get to the detailing stage, some classes will be detailing with AutoCAD while some other classes will be detailing with Revit. And that means you don't necessarily need to install Revit. If you are very good at AutoCAD, there will be different classes for detailing with AutoCAD, while if you are good with Revit, there will be different classes for detailing with Revit. So this is the 3D of it and what we intend to model when we go to Prota-Structure. So this is our first floor. Recalling what we did earlier on the previous video, because of the cantilever that we had at this point, we said when we get to the first floor, these columns in cyan color will terminate, while a beam will extend from this part to this 600 points to be able to carry our 600 cantilever. But we've made a little modification from our previous video because we want to show you something different, and that modification is that on this other end, while we decided to support this cantilever coming here by a beam, we said we are going to run a beam here. This other side, we decided to design it as a full cantilever, so there are no beams supporting it. In this case, it is no longer a cantilever because it has this edge, and this edge supported. But in this case, we'll be looking at how to design fully as a cantilever. If we come back to our Revit model and we'll go to our first floor plan, this is that part we are talking about, having a 600 cantilever. So for this point, we decided to support these columns coming here with this 600 beam. Also at this point, we decided to support this column because you cannot put your column directly on the slab because of punching. But for this other part, there is no need for that. Instead, we are going to design this as a full cantilever. Now we'll be exporting our ground floor general arrangement. So we'll export this in a format that the software will be able to read. So we are using Prota-Structure 2018 version, and I will be saving this as a DXF file format. So after I select the drawing, I will use the block command or press W, and it will bring out this dialog box. So ensure you click on these three dots and it will take you to another dialog box, which gives you the advantage of choosing where you want to save, whether on the desktop or on documents. For me, this is my card folder. I'll be saving as DXF format, so I will come down here and I will select, you can choose any of these DXF formats that you see here, but for this class I will choose AutoCAD 2018 DXF format, and I will change the name of this file to class 1 GA, and I will click on this save button and click OK. So now it has exported my file into my AutoCAD folder. So the next thing is to launch our design software. When you launch your Prota-Structure 2018 version, this is the first screen you are going to see, and this contains a list of your previous projects. But for the reason of this class, we are not opening an existing model. We are concerned about creating a new model. So there's an option for new projects here. So we'll click this and we'll call this class modeling. So remember, your spacebar does not work at this point. So if you want to give some spaces while you are typing, you have to use underscore. So modeling class 1, and we'll click OK. Now it will prompt you to choose your preferred design code. So this depends on your good understanding of the very code you want to use, and it also depends on the location of the structure. But for this case, the structure we are designing for is currently in Lagos, Nigeria. So I'm going to select this BS8110. I can as well use the UK. I can as well use another UK code, which is our Euro code. But for this class, I'm going to stick with BS8110. Let me also throw a little light on this. There is an option for templates here, and there is an option for projects here. So in this template, it shows you a fresh template to start with. But when you come to projects here, you will see a list of your previously done projects. So if there is any code that you've chosen earlier, you can as well come here and select that previous structure which you use that code for. And the advantage of this is it also selects your grade of concrete, your grade of steel, and other necessary details that was in the previous project. So I can just come here and import. But for this case, we are starting afresh, like I said earlier. So I will come back to the template and I will click on BS8110 and tell it to import the parameters of that very code. This is a fresh and a blank sheet. Okay, let me do a quick run through on this interface. So we have here our structure wizard, where you'll be able to see the different stories on this building. You're able to see the columns on each of these respective story. And if you come here, like almost every other software, there is a file tab here that gives you the option of opening, saving, importing, exporting, and the rest. We also have a building setup here that allows you to draw your axes, insert different stories on this software. We also have the concrete members, which allows you to create your concrete members. We have the steel members as well. Then we have the analysis, where we'll go to run our building analysis, and our design tab, where we'll be able to design our different structural members. Without wasting much time, let's start the modeling process. To import that DXF file, we'll come here. We can come here to file, and we'll see model and file import. So we'll go to external reference drawing. Now look at this icon. This is the icon for external reference drawing. There is a shortcut already here for external reference drawing. So I will use this shortcut, and it will prompt me to this dialog box. So I will click on load. So remember, that was the file name that we used to save our our DXF file while we were exporting. So I will click on it and click OK. So I will leave this at millimeter. I will display the text entity so that I can see the various labels if there was any. Then now that you can see here, I've imported this GA, but I want to import the columns and the axes which we created on the AutoCAD. So I will come to this import members option, and I will click on import axis to bring out my axis. So it will prompt me to select the layer which I placed the axis, and it was on our grid layer, as you can remember. So we have different layers here. We have walls, stairs, and the rest. So it all depends on you. So it was on our grid layer, and I will come down here to columns. I will tick this column as well for it to import our column. So it has automatically selected our column layer. So if we created on another layer, we can also modify that. So I will leave both of them in this state, and I will click OK. And now it has prompted me to run a quick building analysis. So this will help you to check if your columns are clashing or if your grids are clashing. So I will run this. I will click this start. You see model check completed, number of errors 0. So we don't have any clashing members on this very file that we've imported. So let's click this cancel and click OK. So it has imported our columns. These are our different columns, while these are our different grids or axes as we created earlier. So let's have a 3D of, let's see a 3D of what we've done imported so far. So I will come here. So if you want to see the 3D of your structure, you have to come to this structure wizard, right click and click on this 3D view. So now it has brought up the column. So remember, the column, this is our ground floor. This is our ground floor that we've imported, and this is the same with what we saw on our Revit. So let's go back to our Revit. So this is our ground floor columns, and if you go to this ground floor here, you will see that this is what we have inserted. All these columns here are what we've inserted so far without this pad pieces, because we've not gotten to the stage where we'll have to design the pad foundation. You see, we've imported our ground floor with the columns. So we want our axis on the architectural drawing, which are this, to be the same with what we have on our structural drawing. So for that very reason, I want to make modification to this axis because they were not named properly. They were named separately by the software. So this is supposed to be our grid 8, but the software has given this very grid as grid 1. So I will right click on this grid, come to right click. So I will click on this grid, right click, come to properties, and you will see the label here. This is the axis label, and I will click on it and change this to 8. And when I change this to 8, I will update and close. I'll do the same thing for this one. This was supposed to be 7, but the structure has given this very grid as Wi-Fi. So I will right click, come to properties, and change this to 7, update, close. Then I will do the same thing for every other grid here. Properties, and for this last one here, we have x1 against a. So I'll quickly right click, come here, and select this, changes to a, update, and close this. So now we've properly aligned this with what we produced earlier. So we created these two grids in order to receive the cantilever slab that is coming at the first floor, and they are at a distance of 600 from grid 1 and a distance of 600 from grid 8. So I will come back here, I will right click, I will click on the grid rather, then right click, then I will come to offset axis. So when I offset axis, then I'll move this to the right hand side and press my F2. So F2 allows you to modify or type the exact length you are moving to. So I'm moving to 800 by the right, so I will type 800 and hit enter. So it has created this as grid 9. So I will come here, right click, go to properties, changes from grid 9 to 8, series, update, and close. Then I'll do the same for this. I'll click on it, right click, properties, no, sorry, click this, right click, offset axis, then press the F2. Because we are going to the left, we are going to type minus before we type any value. So I'll type minus 600 because we are going to the left hand side, and it will automatically create this grid and name it for me. So I will come back to properties, change this to 1, series, update, and close. So now we are set to model. Since we already have our columns, the next thing to do is to start working with our beams. So I will click here. So there are, you can come to concrete member here, concrete member, and since we want to model beam, there is an option for concrete beam here. Or if you look at this icon, it's the same thing with this. So I can click here, or I come and click this beam. So I'll come to concrete member, concrete beam. It will bring out the parameters dialog of, now to bring out the beam properties. So this B represents our thickness. Remember, we are using a 230 wall, so I want the beam to have the same width, and I want the beam to have the same width as our block wall, or as our block wall and as our column. So I will change this to 230 in width, and this H port is talking about our thickness. So if you look at this diagram here, this is what we are talking about. This is the thickness of the beam, while this is the width of the beam. So I want to use a 450 thickness. I'm going to stick with 230 for the width of my beam, while our thickness, the preliminary size, I will go with 450 as our thickness. And let us also be aware that this does not mean this is going to be this does not mean this might be the final sizing of whichever member we are creating. This is our preliminary sizing, so it means after we run the analysis, there will be need to provide maybe a much thicker or a much wider section. It just depends on the load on this very structure. So after doing this sizing, I will come here and I will first of all achieve the beam on this part. So now I have achieved this beam, and I will also draw these edges. Then I will come here, connect this part together, right? So we'll still come to our cantilever. Do not forget that we'll have a cantilever beam at these edges. So we'll also model these parts. So we'll also model on this very axis. Then we'll come to this other grid, model on this axis. So one thing that you will observe while doing this modeling is that once our beam meets a column, it separates it at that point. So that's why we have different name for our beams. So in this case we have 1B6 and we have 1B7. The story one comes with 1, and the B represents our beam, and while the 6 represents our beam number. So if we click on this 1B, if we come here, I will click on this 1B6, this beam will be highlighted. So once it's come to a column, it is going to break off and continue. So this acts like so this is a continuous beam with support at this different point. So I will go back to my concrete beam. I still have this, still use the same beam properties. Come back, model this to this point, and also model this to this point, right? So now I am done with the y-axis. So let me go to the x-axis. We are working with the beam line which we indicated from our AutoCAD that are clearly visible. This is one reason why I like to export, because it will show you positions your beams, your beam lines earlier. So at this point I will also click this part, and here it will terminate on this column, while this other part is going to rest on this other beam. And this is our last point for this side. I'm moving to the right hand side. Our sizing, our beam is going to run from this point to this point, run this from this point to this point. Yeah, so now we've been able to model. Let's have a 3D view of what we have done so far. So I will come to this view and right click, and I will see an option for 3D. So this is what we've been able to do so far. So let's go back to our plan, and remember we have a cantilever at this first floor, right? We have a cantilever at this first floor. So I will come back to the beam and I will click here, and this cantilever 600 to the left hand side. So I will click on this axis, and this is and our cantilever has been created. So how to know a cantilever beam is you will always see this triangle, right, that is pointing to this direction. As we know, our cantilever is only supported at one end while the other end is free. So if at any point in time you saw that this triangle is appearing on any of these beams, so it means that beam has been cantilevered. So you always have to check out for that. Remember, I said whatever you give to the software is what the software is going to give to you. So you should be careful while you are doing your modeling. So let's have a walkthrough. If we have any of those triangles, I cannot spot any of them here. So with that, let's continue. We come here and we'll model from this point to this point as well. You can see our cantilever sign is back. We'll model this and we'll model the last one. Now that we are done, let's have a 3D view. Let's see the 3D view. So these are our cantilever. Now do not forget that we did not insert this beam here because we are designing this part here as a fully cantilevered slab. Let's start to insert our slab. We can come to our concrete members and click on slab, or this same icon you can also find it here. So this will open up my slab dialog box, my slab properties dialog box. So this is our slab label, which is the label our slab is going to carry, just like our 1B1, 1B6 and the rest. So this is the slab type. You have different slab type. You have the one that is supported at all edges, supported at 3 different edge, and 1 edge is free. So we have these different properties, but we are going to stick with type 1 for now. We'll look at other types, and our preliminary sizing, we want to go with a 150 mm thick slab. So for that, I will change this to thickness of our slab. The H represents our thickness, so I will type 150 here, and I will come to the concrete cover. The concrete cover here is 25. For our slab, we can decide to assume the thickness, but for our concrete cover, we have to make proper reference. Now this is very, very important because it helps to protect our reinforcement against possible defects. Now these defects, we are talking about cases of corrosions. It also helps in resisting fire from getting to the reinforcement in case there is a fire outbreak on a particular structure for a specific amount of time. So let's consider some factors that will enable us choose the appropriate concrete cover. Firstly, let's look at the size of the aggregate we intend to use for construction. So the size of this aggregate should not be greater than the concrete cover. Let's assume we are dealing with a column. In the process of concreting, it has to go from the top to the bottom. So the concrete cover is the space between the reinforcement, including the links to the end of the concrete or the position of our formwork. If the aggregate size is bigger than the concrete cover, there might be possibility of not having a free flowing concrete, and this process can lead to honeycombs. Now, why these considerations are important at this stage is so in case we get to cases of foundations and we are using a higher concrete cover, we understand the concept and the reason behind those assumptions. And secondly, we look at the exposure categories, and these exposure categories, they are listed here. So ours falls within the mild category because the concrete surface is protected against weather or aggressive conditions by the reasoning of our plastering and finishes. Now let's also look at how many hours we want our concrete cover to resist a fire outbreak. So this 1.5 hours still falls for this is for our beams and this is for our floors, which are our slabs. So 1.5 hours falls under 25 as well. So 25 has satisfied this condition. It has also satisfied the condition of exposure. Then also our concrete size, we're taking a maximum of 20 to 25 mm of coarse aggregate. I'm going to stick with this 25 mm for this concrete cover. Now let's come to the loading tab, and if you look at these slab properties, we have two different layers here. We have the general and we have the loads. So we have our self weight, which has already been calculated by this thickness and the weight of and the specific weight of concrete. And now we have to specify our dead load. So before we consider this, we will start with this impose load. Imposed load deals with the reason why we are designing this structure. So we are designing a very simple residential structure. Kindly recall that at the start of this lecture, we selected BS8110 as our design code. Another nice thing about the software is the moment you select a code, it makes reference to relevant code. So if BS8110 is making reference to other BS code, let's say BS5950 for our steel, the software automatically selects all those codes and impute it in the software. So let's take a look at this analysis tab and come to building analysis, and we'll click on these parameters. So on the parameters on our code, you'll see we have BS8110 1997, which we checked earlier. And in case we are doing anything with steel, it has already provided BS5950, which is the structural use of steel work in building. And for our loading, is which we just checked now, is our BS6399. So you can also modify this and select a different code, but we are sticking with BS8110 and its relevant code. So this is where it was able to get our loadings from. Let's say you are designing for a hotel. The loading for a hotel and the loading for a simple residential structure are different because of its functionality. And if you are confused on the value to use, you can make reference to table 5 of that particular code. We'll come here, click on this slab. We'll change this back to our 150, and our impose load, we are going to right click and use general domestic use, which is 1.5. Then our dead load, we are going to consider two things. We will consider our partitions and our finishes. Consider partition as 1.2 and finishes as 1.0, a total of 2.2. So now our slab properties is complete. So we'll come here and we'll place our first slab. Then we'll continue to position. Just click in between the beams and you'll be able to position your slabs. So we'll go ahead and close this, and let's have a 3D look of what we have done so far. So this is our slab. So we've successfully inserted our slab, and let's come back to our plan. So let's go ahead and model this part over here. Instead of insert, we've changed the mode of insertion. So by that, if we click on this insertion here, the first one we inserted was our beam region. So once you take your mouse to a beam, it will automatically place in within the region of that beam. So in this case, let us do something different. We want to put it in axis region. So I will come axis region and I'll click on this axis. So it has created this slab for me along this axis. For this case, we have another grid in between these 2 points where we want to insert. So we'll change our mode of insertion to pick axis. So this will allow us to modify or select the axis we want to insert this slab independently. At the start here, we have our D prime. So it starts is going to start as our D prime, and it will move to this other grid, which is our grid 1. Then it will return back to this other grid, which is our intersection of grid 1 asterisk and C. So I will start with grid D prime. I'll click on this grid. I'll click on this one. I'll click on this, and I will return back to our D prime. So it will insert within those axes that I have picked. And just come to axis rejoin and click. So now I have successfully inserted my axis. So now we've successfully inserted our slab. So let's look at what we've done. So these are now our slabs that we've inserted here. So the next thing we have to model is our cantilever slab at this edge. So far you found this video interesting or helpful to you. We appreciate if you can give us a like, subscribe to our channel and turn on the notification bell. You get notified when we upload new videos. It helps us so much and gives us the zeal to do more. Come back to the slab, and in this case I will not stay with type 1. I will come here by type 12. So if you look at it, you see that it is only one end that is supported, and I'm sticking with 150 thickness, and our loading is still going to be the same. We are sticking with this, and our L count. So our L count talks about the width of this cantilever, and you remember our width has always been 600. So I'm going to type 600 here. The width of the cantilever, I will type 600 here. You have to draw from your start to your end of your support, then you take it to the direction that you want to insert this cantilever. You're inserting at the right, so we'll click here. So our 600 cantilever towards the right has been created. We'll also move from these two supports and come to this point, move from these two supports, and we are moving right. Yes, so we'll close this, come back to our 3D, and these are now our cantilever slab. Go ahead, I will head back to our plan, and I will save this model. So we have done with modeling the first floor. Now we'll be stopping at this point, so kindly look out for the part 2 of this video to see how we're able to complete the modeling. Thank you for staying with us till this time. Kindly like and subscribe if this video has been helpful to you, and let's call it a session.